In microservices, when we need to handle transactions across multiple services, we use a design pattern called Saga. The Saga pattern describes a way for microservices to coordinate and communicate with each other in order to support a global transaction across different databases. As shown in the illustration, we can have three separate services, and each service has its own database. When a service interacts with its database, it performs a local transaction. Saga helps us coordinate multiple local transactions into a larger transaction that spans across different services in the system. Two ways to implement Saga. 1. Choreography. In choreography, services communicate directly with each other by sending messages. There's no central service to manage the flow. The coordination is fully decentralized. Example, let's say we want to create an order. The order service creates a new order with the status pending. A pending order means the process hasn't been completed yet. When querying orders in the system, we skip those with the pending status because they are still being processed by other services. The order service then sends a message to the inventory service. The inventory service receives this integration event and checks if there's enough stock for the order. If stock is available, it sends a message to the payment service to process the payment. Once the payment is successful, the payment service sends a payment approved message back to the order service. The order service then updates the order status to created. In this flow, all three services communicate with each other through messages, and each performs its own part of the transaction. What happens if something goes wrong? Let's say the inventory reservation succeeds, but the payment fails. The payment service will send a payment rejected message to the order service. The order service will update the order status to rejected. It will also send a message to the inventory service to undo the reservation. In another version of the Saga, we might decide that only the order service should handle rollback coordination. So, the payment service sends a failure message only to the order service, and then the order service will send a message to the inventory service to cancel the reservation. This means that as a developer, you are responsible for designing the Saga, deciding how services coordinate to minimize complexity and avoid errors. Maha 2. Orchestration. In orchestration, there is a central service, usually the order service, that controls the entire flow. Instead of services messaging each other directly, the order service sends commands to the other services one by one and waits for responses. The order service calls the inventory service. If inventory is available, it then calls the payment service. After receiving a successful response, it updates the order status from pending to created. If payment fails, the order service sends a command to the inventory service to undo the previous step. Orchestration can be implemented not only with message queues, but also by calling APIs directly. Challenges in implementing isolation. The I in ACID. In traditional transactions, isolation means operations inside a transaction are invisible to the outside until it's complete. In Saga, we lose this isolation. For example, an order created in the pending state can be read by other parts of the system. It's just stored in the database. So when designing sagas, we need to define rules and conventions to avoid other components reading incomplete or temporary data. 2. Idempotency. Idempotency is critical in Saga. A service should behave the same way whether a message or API call is received once or multiple times. Make sure your service logic can handle duplicate events or retries without side effects. 3. Ordering independence. Try to design your Saga so that steps can be performed in any order or retried in case of failure. This makes your system more robust and fault-tolerant. In conclusion, Saga is a powerful design pattern that helps us handle distributed transactions across services. You can choose choreography for flexibility and decentralization, or orchestration for more control and coordination. Either way, you need to carefully handle rollback, idempotency, isolation, and ordering to ensure your system works correctly under all conditions. Nếu bạn muốn mình có